Demand side management means the electricity supplier supporting the customer to make an impact on the electricity supply system such that the supplier saves investments and operating costs, and the customer also saves on his electricity bill. Now, if one may ask, what is the greatest technical problem in Sri Lanka's power system today? It is demand side management, or more precisely, the absence of demand side management. Sri Lanka's electricity demand has a very low requirement after midnight until about 6 a.m. This is because Sri Lanka's industrial base, industrial customers using electricity as a proportion is much smaller than other types of daytime and evening customers. Therefore, there has to be a special effort to create a demand in the off-peak period by shifting some of the consumption during the daytime as well as in the peak time, such that the power plants can operate more efficiently overnight and thereby reduce the total cost of operating the power system. The ways of doing that are many, and implementing demand side management is definitely more difficult than building a new power plant because it involves a large number of customers, a lot of real solid engineering, power engineering, human behavior, financial and economic and technological innovation. So you could create demand in the off-peak period by, on the system side, using pump storage power plants. But that's something that has to be done by the electricity supplier. What involves the customer, if I may give a few examples, using chillers to manufacture chilled water overnight and chilled water to be used for air conditioning during daytime. Practiced widely in South Asia and Southeast Asia, but not in Sri Lanka. Electric transportation. The next generation of electric vehicles would be plug-in hybrids, and in time to come, when the battery technology and the economics are right, it will be all electric. So all electric vehicles would have to be recharged overnight, and that's something that can create a demand in the off-peak period. Similarly, railway electrification. Of course, in the night time there will be no significant demand, but it can very significantly assist in managing the demand in the two valleys that you see in the load profile between 6 a.m. and 8 a.m. in the morning, as well as between 5 a.m. and 6:30, between 5 p.m. and 6:30 p.m. in the evening. So these are some of the initiatives that one could take. Of course, what advanced countries are researching on are more smart techniques to keep the customer informed about the price of electricity at any given time, so the customer makes a decision. And the customer can also make a decision to give the control of his appliances to the electricity supplier. For example, a washing machine does not need to run at the peak time. Customers can give the control of their washing machine to the electricity supplier so that he only loads the clothes and pushes a button. And it will actually start when the electricity supplier sends a signal, at a time when the electricity supplier knows it will be the cheapest to provide electricity for those washing machines. So these new, relatively simple and slightly technologically advanced techniques are coming in, and we need to be aware and study them and implement them rapidly, so that the number one problem that prevails in the Sri Lanka power system, the problem of not having adequate demand in the off-peak period would be solved in the most innovative manner from an engineering and economic point of view.